I'm Stats Medic, and in this lesson we're going to be learning about confidence intervals for a difference in proportions. We've got two learning targets. The first is to determine whether conditions are met for doing inference about a difference between two proportions. And then the second, we're going to construct and interpret a confidence interval for a difference in proportions. All right, so let's take a peek down at the notes. So in this lesson today, what we're going to do is we're going to take everything we know about one sample confidence intervals for proportions, and we're going to extend it to two sample confidence intervals. So our context here, we're looking at which grade is more likely to go to prom. So at many high schools, prom is an annual dance that we have for juniors and seniors only. And the student council at a large high school is wondering if juniors or seniors are more likely to attend prom. They take a random sample of 50 juniors and find that 28 are planning on attending prom. And then they select a random sample of 45 seniors and 29 of them are planning on attending. Construct and interpret a 95% confidence interval for the difference in proportions of juniors and seniors who are planning on attending prom. So before you get started here, I want you to notice some key language. So we've been asked to construct and interpret a confidence interval for the difference in proportions of juniors and seniors planning on attending prom. So we notice right away here that we're looking at finding a confidence interval for a difference. We also can tell this pretty quickly because we have more than one random sample. We have a random sample of juniors and then also a random sample of seniors. So this type of confidence interval is different from what we've done before. Before, when we did a one sample confidence interval for a proportion, we would only have one sample and one proportion. But now here we have two different samples and then also two different proportions. So what I'd like you to do is to think about, okay, what do I already know about confidence intervals for a single proportion? And then we're going to take that knowledge and then we're going to extend it into a confidence interval for a difference in proportion. So take some time to work through all of the problems below here. So you're actually going to work through this whole front page. Pause the video, and then when you're done going through the questions, push play, and then we'll go over the answers. All right, so let's see how it went. So in number one, we're starting by trying to figure out what our point estimate would be. So again, we have two different proportions given in this problem. So we have a proportion for juniors, and we've been told that there are 50 juniors sampled and 28 of them plan on going to prom. So our estimate, or our point estimate for the juniors would be p hat 1, which is 0.56. And then we do the same for the proportion of seniors. There are 45 seniors and 29 of them are planning on going, which is a proportion of 0.64. And then we're asked to find the difference in the proportion of juniors and seniors planning on attending prom, which is given here now as p hat 1 minus p hat 2, and that's negative 0.08. And that negative is important here. We were told in the problem that we're doing juniors first and then seniors, so order matters. You have to be careful about your order, so make sure that you're doing it in the order given, or if you're not, you have to note somewhere which proportion goes with which sample. So our point estimate here is going to be p hat 1 minus p hat 2, which is negative 0.08. Okay, next we're looking at conditions. So you probably wrote something about random sample in a check. Now here there's some stuff we actually need to add. So what's important here is it's not just a random sample. There were actually two random samples. So I'm going to add an S onto here and I'm going to underline that. That's actually very important. When you're doing one of these confidence intervals on the AP exam, you have to make sure you're noting that there is more than one random sample. Now, if you just want to write random sample, you need to make that plural, or you can give both of the random samples. So actually what I would do here is I would list out that there was a random sample of 50 juniors, and then also a random sample of 45 seniors. It might sound silly, but a lot of people forget to add that plural onto the random sample. So as long as you list both samples, then you're safe. Now, additionally, there's one other thing we need to add here, and that's that these random samples are independent random samples. When you're doing two sample inference, if you're using random samples, it's important that they're independent random samples, meaning that one sample does not affect the other. So an example of that in this case would be that like a junior can't also be a senior, so there's no overlap. That's one way you could explain this. All right, then next we're going to do the 10% condition, and just like we did with random samples, you need to check the 10% condition for both populations. So I've got juniors and then also seniors, and check both of those. And then for large counts, also again, we're checking for both samples. So make sure you have everything listed for both the juniors and seniors. I've got n times p hat, so 50 times 0.56 is the 28, and then also 50 times 0.44 is 22. Both are greater than or equal to 10. And then I did the same for the seniors and got 29 and 16. Again, all are greater than or equal to 10. So you're actually doing large counts, thinking about you're checking it 4 times, meaning checking the successes and failures for both samples. All right, now we're going to get into actually creating our confidence interval. So whenever we've done confidence intervals before, we've always used a general formula of point estimate plus or minus margin of error. Well, our point estimate here, we started by figuring out our point estimate was this p hat 1 minus p hat 2, or negative 0.08. So what I've done here is, when I fill in my specific formula, I'm putting this in as sort of like a placeholder. So I like to put parentheses around it. So I remember, okay, it's really just this one thing. It's negative 0.08. And then my margin of error from earlier confidence intervals, I remember it's my z star times my standard deviation. So I've got a z star again here. And now I know from sampling distributions of a difference in 2 proportion, the standard deviation is this formula here, this large square root. Now, one thing that's really, really important is look at your paper and see, did you use P1 or did you use P hat 1? So actually on both of the P1 and P2, those all need to have hats on it. We don't actually know the true population proportions. If we did, we wouldn't need to do a confidence interval. So it's really important here that you have hats on all of those proportions. And then I just went ahead and plugged all of that in. So I've got down here, again, my proportion, or I'm sorry, my point estimate was negative 0.08. The z star for 95% is 1.96. Plugged in all of my values, and I got negative 0.08 plus or minus 0.20 is my margin of error for this final confidence interval of negative 0.28 to 0.12. All right, so our conclusion, same as before, we're 95% confident that the interval from negative 0.28 to 0.12 captures. And then what's important here is you're just relisting your parameter, the true difference in proportions of juniors and seniors planning on going to prom. And what I love about confidence intervals is you can always get that from the stem of the problem. We were asked up here to write a confidence interval for, and then I have again listed all this stuff here. So I'm just taking that exact wording and copying it down for my conclusion. So in this last question, we're asked to take our confidence interval and make a decision. So does the interval provide convincing evidence that juniors have a lower proportion planning on going to prom, or is it plausible that there is no difference between the 2 classes? Well, what type of value would we get if there is no difference between the 2 classes? So if I took P1 minus P2, what would show me there was no difference? Well, that would be 0. If I get P1 minus P2 equals 0, that means there's no difference. So I'm looking to see if 0 is contained in this interval, and it is. So it's plausible that there is no difference between the 2 classes because 0 is contained in the interval, meaning we would not have convincing evidence of a difference. And what I want to note here is, well, the way that I know that 0 is contained, a nice way to check quickly is, well, my interval went from negative to positive. Well, what if there had been a difference? What type of interval would I have gotten? So down below here, what I want to do is I'm going to write, what if we had gotten a positive interval? Well, positive interval would have meant that there was a higher proportion of juniors planning on going to prom. Okay, well, what if we had gotten a negative value? Well, if I take 2 values and subtract them and I get a negative, that means the second thing had been higher. So in this case, that is a higher proportion of seniors would have been planning on going to prom. And then in our case, we had gotten a negative positive interval, which means that there could be no difference. So that's how you can use your confidence interval to make a decision about if you have convincing evidence of a difference. If you get a positive interval, then the first thing is greater. or the first proportion is greater. If you get negative negative, then the second proportion is greater, and if you get a negative positive, well, we don't really know, so it's plausible that there could be no difference. So let's go through our important ideas. So we had two learning targets. The first was about checking conditions, and then the second was about constructing and interpreting a confidence interval. Really, we can sort of wrap that all into one. So what I'm going to do here is I'm going to write this as a confidence interval for P1 minus P2. And if we are asked to construct and interpret a confidence interval, that means we are doing our full 4 steps, our state, plan, do, conclude. And what's going to be different on here, when I start in the state portion and have my parameter, it's going to be P1 minus P2, which is the true difference in proportions. And when I write all this up, I'm only going to write the things that are different compared to when we're doing a confidence interval just for P or for one proportion. So in the state portion, we are doing our parameter and our confidence level, but the parameter is the only thing that's changed. For the plan portion, what is different is the name. So this is a 2-sample Z interval for P1 minus P2. And for my conditions, as we talked about on the last page, it's not just a random sample or random check. We need to make sure that we have independent random samples. And then you are referencing that both of the samples are random and also they're independent. Then we're also going to have the 10% condition, which you check twice, once for each sample. And then also we're checking large counts. Again, you're checking that for both samples. All right, in the do portion, it's still going to be your point estimate plus or minus margin of error. Nothing's new there. But my formula then, my point estimate is going to be P hat 1 minus P hat 2. I like to think of that in parentheses as it's just this one value that we figured out. Plus or minus your Z star times your standard error, which is this big formula. Be really careful with your values there. It's very easy to mix those up. And then the last portion is the conclude. And I'm just going to put in quotes here the start of that. That is our conclusion, our interpretation. We are 95%, ... or whatever percentage you're doing. All right, and then one additional thing we talked about on the last page is we talked about how do you know if you have convincing evidence based on your confidence interval. So what I'm going to put here is convincing evidence, question mark. And if you have an interval that is positive, positive, what that is telling you is that the first proportion is greater. If you get a negative, negative interval, that means our second proportion is greater. And if you get a negative positive, that is telling us we do not have convincing evidence that there is a difference. And the reason that is because our interval contains 0. Okay, so give the check your understanding below a read, take some time and work through. I've given you the full 4-step template on there, so So you can use that as a fill in the blank and to sort of help you work through the problem. When you're done, hit play and I'll go over the answers. All right, so in this context here, I want to point out a couple of things in the parameter. So we've been asked to construct and interpret a confidence interval 4, and then everything after that 4 is my parameter. Now I do need to add my symbols, so I use subscripts of T and N for teachers and nurses. So for my parameter, I did P sub T minus P sub N, or in other words, that is the true difference in the proportion of all teachers and nurses who have a second job. Now it's pretty easy to see here what order of subtraction I did because of my subscripts. However, I do always like to put in parentheses at the end my order for subtraction. So I'm going to do teachers minus nurses. And then I'm doing a 95% confidence level. I like to write my statistics to the side, so I've got these over here. It just helps me keep them straight for later on. I don't have to go back into the problem and find them. All right, our plan portion. This is a 2-sample Z interval for PT minus PN. So some things I want to make sure you have on your conditions. For the random condition, you want to make sure that you have that this is independent random samples. You cannot just say random sample. For one, it's got to be plural. You have 2 different samples. I wrote them directly from the problem, so random sample of 150 teachers and a random sample of 100 nurses. But then also you have to make sure you have somewhere that they are independent. 10% condition, I checked that 2 times for each sample. And then my large counts, I've checked for both the teachers and the nurses. All successes and failures are greater than or equal to 10. Now, I also wrote in here down below the so what's. Why are we doing these things? Well, for a random sample, we're doing that to check to see if we can generalize to the population. The 10% condition, that allows us to sample without replacement. And then my large counts condition is so that the sampling distribution of P hat T minus P hat N is approximately normal. All right, then the do portion, my general and specific formulas. I've got a general of point estimate plus or minus margin of error. So specifically, I filled in all my variables there. I'm not going to read those off. And then plugged in all of my values over here. Typed them in my calculator, and I got a final confidence interval of 0.001 to 0.219. So for my conclusion, we are 95% confident the interval from 0.001 to 0.219 captures the true. And then I've used, again, that exact wording from up here, just stemmed it from the problem. So that is the true difference in proportions of teachers and nurses who have a second job. Again, I would write in parentheses the order of your subtraction. And if I were asked a follow-up question about if we have convincing evidence of a difference, we do, just barely have convincing evidence. So we have a positive interval, which means the first proportion is greater. So we do have convincing evidence that there is a higher proportion of teachers with a second job than nurses. That is often a follow-up question to a confidence interval on the AP exam. So that would be helpful for you to be thinking about that also.